stellar gas and dust. The youngest clusters appear as clumps of gas, glowing in ultraviolet light from the young stars within. Near the center of the galaxy lies a cluster of hundreds of massive blue stars, each more than 10,000 times brighter than our Sun. Around the cluster is a vast heart-shaped bubble, inflated by stellar winds and radiation from the young stars. 30 million light-years away, Hubble saw the magnificent galaxy NGC 1512. The barred spiral galaxy is forming new stars in both dusty and clean regions. This image was developed from 7 separate pictures taken with 3 Hubble cameras in all wavelengths of light, from infrared to ultraviolet, the Faint Object Camera, the Wide Field and Planetary Camera 2, and NICMOS, the Near-Infrared Camera and Multi-Object Spectrometer. This compelling image of the Whirlpool Galaxy M51 is a brilliant example of the astounding detail Hubble provides. The composite picture reveals both visible starlight and light from glowing hydrogen in the spiral arms. Tugging at M51 is nearby galaxy NGC 5195. Its gravity is triggering star formation, seen here in luminous clusters emitting glowing red hydrogen. The Whirlpool Galaxy is 37 million light-years distant. Barred spiral galaxy NGC 4314 lies 40 million light-years from Earth. Its core is surrounded by an unusual ring of infant star clusters. This ring is the only region in the galaxy that has given birth to stars in the last 5 million years. The ring has a pair of spiral arms packed with young stars, making the core itself resemble a miniature spiral galaxy. When the antennae galaxies collided 48 million light-years away, over 1,000 bright young star clusters burst into life. This gave scientists an outstanding opportunity to study the birth of stars and star clusters. Colliding galaxies have already taught us that the formation of globular star clusters has not subsided, and that star clusters are born from clouds of cold hydrogen squeezed by collisions with hot gas. 50 million light-years from Earth in Ursa Major, a bubble of hot gas is rising from the glowing core of galaxy NGC 3079. The bubble was probably created by high-speed particles released by star formation. Over 3,000 light-years wide, the bubble has risen 3,500 light-years above the galaxy's disk. Gaseous filaments at the top of the bubble are being expelled into space and will eventually rain back onto the galaxy, possibly forming a new generation of stars. The 4 towering gas filaments on the bubble are each about 75 light-years wide, rising at more than 4 million miles an hour to disperse at a height of 2,000 light-years. About the same distance away, NGC 4438 is also blowing extremely hot bubbles of gas into space. But these are coming from a massive black hole, voraciously consuming the material around it. The 800 light-year wide bubble is rising from a dark band of dust within the oddly shaped galaxy. Below the dust band, another bubble appears in the form of dim red blobs. One side of the bubble is lit by a jet of gas ejected by the black hole that has crashed into a denser body of gas. 50 million light-years from Earth, the region surrounding a black hole in galaxy M87 is emitting a focused stream of subatomic particles, moving at nearly the speed of light. The hole has swallowed 2 billion times more matter than exists in our Sun. It is surrounded by a hot disk of gas, densely laced with twisted magnetic fields. Electrons traveling along the lines of these fields produced the blue ray that stands in vivid contrast with the golden glow of the stars that compose M87. Galaxy ESO 418008 is a small young spiral, similar to the thousands of dwarf galaxies that scientists see in Hubble's deep surveys. The galaxy's stars are segregated by age. The older red stars are in the center, and the younger blue stars lie in the spiral arms. Even at 55 million light-years away, only half of NGC 4013 can fit in Hubble's field of view. The edge-on view of this spiral galaxy reveals a 500 light-years thick ring of red dust around the galaxy's plane. New stars are forming in the cloud, emerging in blue clusters when the dust disperses. Several new clusters, similar to those in the Milky Way, adorn the galaxy's equatorial band. NGC 3310, 59 million light-years away, is another starburst galaxy rife with new stars. Tracing the galaxy's spiral arms are hundreds of bright blue clusters, each holding about 1 million stars. They have formed in the last 100,000 years and are being joined continuously by new stars and clusters. The clusters gradually become redder as their bluest and most massive stars exhaust their fuel and burn out. Majestic spiral galaxy NGC 4414 was imaged by Hubble's Wide Field and Planetary Camera 2 through 3 different color filters. Measuring the brightness of Cepheid variables tells us this galaxy is about 60 million light-years distant. It also helps calculate the rate of expansion of the universe, the Hubble constant. The value derived is then used to determine the distance, size, and luminosity of other objects, and to measure the age of the universe itself. Even at an amazing 72 million light-years, Hubble can still see details in galaxy NGC 7742. Its spiral arms, for instance, are wound unusually tightly, and its center is ringed by a region of active starbirth. This is a Seyfert II active galaxy, a spiral with a very bright center harboring a massive black hole. Uniquely, the intense luminosity of Seyferts can change in any part of the spectrum within just days or months. Perhaps the most compelling of all the images Hubble has sent are those from the distant boundaries of the universe. So unimaginably far are the objects in these pictures that the light by which we see them was emitted billions of years ago, about 1 billion years after the birth of the universe itself. And the farther we look into the distance, the deeper we see into a past that is staggeringly ancient. 100 million years ago, these galaxies collided, leaving a pipeline 20,000 light-years long. The Space Telescope imaging spectrograph on Hubble shows gas flowing from NGC 1410 on the left to NGC 1409. The collision ignited several clusters of bright blue stars in 1410, but none in its partner. The gas inflow may be too small or too hot to form stars. Spiral galaxy NGC 4603, 108 million light-years from Earth, is part of the massive galaxy cluster Centaurus A. The cluster's gravity is so great, it is pulling the entire local group of galaxies towards it at more than 1 million miles an hour. 4603 is the farthest galaxy we know containing Cepheid variables. Astronomers use the pulsation of these stars to calculate their distance from Earth and to measure the expansion rate of the universe. NGC 4622 is rotating clockwise, though its arms suggest it should be turning counterclockwise. The arms of most spiral galaxies trail behind, but not these. Oddly, 4622 also has an inner arm wrapped opposite to the outer arms. The anomalous spin may be the result of an encounter with another galaxy, a history suggested by the lopsided outer arms of this galaxy. Hubble looked 114 million light-years into space to see 2 spiral galaxies swinging past each other. Strong tidal forces from NGC 2207 on the left distort its partner, pulling from it streams of stars and gas 100,000 light-years long. Calculations indicate the 2 will pass, but the gravity of the larger 2207 will eventually pull the smaller galaxy back and swing it around again. This rare and mysterious polar ring galaxy lies 130 million light-years from Earth. The galaxy may be what's left of 2 galaxies that collided 1 billion or more years ago. The inner rotating disk of old red stars would be the remains of the larger of the 2. The second would have been scattered, its stars, gas, and dust